Good morning, scholars. Today we're going to be covering two new concepts. The first is going to be area, and the second is going to be circumference. These two units of measurement are designed to figure out and quantify various aspects of a circle. Our first area is going to account for the physical space within inside of a circle, and circumference is going to be essentially the perimeter or the length of distance around a circle. For today's lesson, all you're basically going to need is a pen, a pencil, and if you do have it, a compass, or just another figure that you can use to write a circle, such like the bottom of a cup or soda can or something like that. So let's take a look at our notes for today. You'll see here already we have written out area and circumference for today. So make sure you got that on top of your notes so everything's nice and organized. Our first term, as mentioned before, is going to be area. Area is all the physical space that exists inside of a circle. We've spoken about area once before in our class when we were referring to various types of quadrilaterals, and we're trying to find the amount of space that something takes up. Circumference is going to be like a concept more related to perimeter, which was like the outside of our classroom, like the box walking around it, or the block around our school. And area is the amount of space it would take to walk back and forth every little step inside of our school and every individual hallway and row between our desks. So area is going to be a larger number, circumference is going to be a little bit smaller, but we're going to use a concept called pi to calculate all of this out. But let's take a look. Our first equation that we're going to have is going to be for solving for the area of a figure. The area of a circle, or and this is any circle, is going to be the number pi times our radius squared. Or you can call that pi times the diameter divided by 2 squared. So pi is not a word that we've come to talk about much before. But pi here we can call, it's a number that essentially allows us to represent the ratio between circumference and the diameter. We're going to look at the ratio of the circumference of a circle and its diameter. When we're talking about ratio, to bring it back in the past, we're talking about like a 16:9 aspect ratio, like on a television. There's a ratio that exists between the diameter and the amount of length or distance around a circle. The number pi is really interesting though. Mathematicians have tried to solve this particular number out before, but they've never been able to quite qualitate it to its most precise digit. Some people theorize that technically pi could be an infinite number, or as in the decimal points going after what's commonly known as 3.14 can go maybe a million digits, maybe 2 million digits. You can also go on YouTube and watch videos of people trying to memorize as many possible digits as they can. And we're talking like hundreds or thousands of digits here in terms of like the efficiency that some people can do. Some have memorized it so well that they almost pick up patterns that exist inside of it. But some mathematicians also describe the number pi as irrational and that it technically never repeats and that there's always some variability or no specific pattern that exists within all of those decimal points. In comparison to say something like the number 1/3, which is just 0.3 repeating, there has a pattern there versus pi, which is believed to be ridiculously long and nearly infinite. But for the purposes of our course and for most people's just memory in general, we're looking at 3.14. Allows you to punch that number in or do it in your head and get pretty much the accurate. This circle as an example in terms of qualitating or quantifying area. This circle, we just used our compass to make a nice little round figure here. Always make sure that when you're going to draw your circle out, you always fill in your starting point, your center point, if you will. That way you can always reference back. But this particular one, we're going to say we have a reference or a radius of 4. If we have a radius of 4, what would our diameter be? If you guessed 12, you'd be wrong because our diameter is just going to be half our length available. Radius is going to be twice or half the length of our diameter, so we can do 2 times 4 and get a value of 8. If we were to set up an equation, say, to solve for area, we're just going to input our values in. So our original equation is area is equal to pi times our radius squared. We can fill this in here. Pi times 4 squared. 4 squared is going to be 16. And typically the way that this is written out, normally you don't solve for pi, you don't put pi necessarily in the calculator, you don't do 16.1, or sorry, 16 times 3.145, yada yada yada. You just leave your answer as 16 pi for your area. If we were going to express this just as a means of using our diameter, let's say area is equal to pi times our diameter divided by 2 squared, or 8 divided by 2 squared, which is the same thing as saying 4 squared once again. And obviously we're going to get the same answer once again. You might just have to do an additional step. So we end up getting 16 pi as our answer. And just remember, in terms of writing that material down, it's going to be the whole number followed by your pi symbol. And you can just leave it as that. You don't have to do any additional extra work there. Next thing we're going to take a look at, if you go to your following page, is we're going to be working with our circumference. The circumference is the length, essentially, or like in similar fashion, the perimeter around a circle. You can say as our definition, the distance around a circle, i.e. perimeter. Perimeter we typically don't use with the word circle, we just stick to the word circumference, but as an example we can say perimeter. So our equation is going to be different than our area. As you can guess, the circumference itself, just that measurement, just like the perimeter in comparison to area, is going to give us a smaller number. The equation that we're going to have set up is we're going to use the letter C for circumference. And we're going to say circumference is equal to 2 times pi r. Or, what's a bit easier, is pi times your diameter. So we can do either or, just depends upon your graph and what information you're given. It might just be easier if you see your radius to then just double it and then have your diameter there and punch that in. So let's take a look here. I'm going to draw another circle here. Once again, I'm going to fill my center point in first, in case I need to come back and check. Come around. And let's first start with So going from one point to the opposite side through our center is going to be essentially the definition of a diameter. So we could say our diameter is going to be 12. If the diameter is 12, what is our radius going to be? All right, so for this particular one, we can say our radius would be 6. Our radius is just going to be half the length of our diameter. So we just do 12 divided by 2, or half, and get the value of 6. Okay, next thing. Let's fill in these values. If we're going to work with our radius in terms of solving for our circumference, we're going to do c is equal to 2 times pi times 6. And what we can do here is basically just multiply 2 and 6 and get a value of 12 times pi, or 12 pi as our circumference. In a similar fashion, if we're using our diameter example, we can do just 12 times pi. And you can, of course, just leave it as 12 pi. You don't need the multiplication symbol in there if you don't want to. So this is how you go in one direction. If we're told the area of a value, or if we're told the circumference, say, like for instance, if we're told the circumference of a circle is 30 pi, we can say that the diameter would be 30 and our radius would be equal to 30 divided by 2, or 15. So we can use that formula essentially to go backwards as well too, such that 30 times pi would be equal to d times pi, or 2 pi r would be equal to 30 pi. Divide 30 by 2 gives us 15 pi. Divide pi by both sides leaves us just with 15 is equal to pi, equal to our radius. All right, so now I'm going to give you a couple examples of what questions might look like. I remember the one I'm going to show you right now is, I think if you know your formula, it's a very simple question. But when I was taking my math regents, I remember this one, it's still in my mind, this particular question. I could not get it for the life of me because I didn't have the equation memorized. And that's where it's always important to study before your exams. Always, always, always important. But we're just going to compare two circles right now. The question I got when I was all your age, we had two tires, like bicycle tires, say. One had a diameter of 70, the other had a diameter of 50. And what we'll see here, I drew these slightly different. They almost look identical though. But we'll imagine that artistic ability coming out, and we'll say we have two different size like tires here. So this one's going to be 50 for our diameter, 70 for our diameter, and we can go ahead and say centimeters for our figures. One question you might be asked here is what is the length of one revolution? What is the length of one revolution? All right, so now we have to come and think about what specifically is being asked. We have length here. Length, we talked about distance in our circumference. So it's kind of giving us a clue there. And then revolution as a term, dating back many centuries, basically means circular. Today we think about the term revolution in a post-French Revolution world as something was a new starting point. Prior to the French Revolution, the term actually meant to come back around, as in time periods were cyclic or circles. To compare these two, we could say that the length of one revolution for our smaller tire would be 50 times pi would be equal to our circumference. So one revolution for our small tire would be 50 pi, and one revolution would be 70 pi. This is another example of how these questions are presented. This is the one that always got in my head as a kid. I always forgot it in my geometry regions back in high school. I wanted to show you these two today as a little helpful hint. This portion, I think, of our unit is one of the easier portions in our circles. Circumference and area, they're very, very neat and formulaic equations that we can just drag and drop information in. The thing that you need to be considerate of is which direction you're working through your equation. Are you being given the circumference already, and then you have to work back to your diameter or your R value, or are you being given the radius and the diameter and you have to work up towards your circumference or work up towards your area? So just like an algebraic question, you need to kind of see which direction you're going back and forth in those equations. So that's it for our notes for today. This lesson's a slightly shorter one. You do have in Google Classroom a set of independent practice questions that you can answer today. As a reminder, when you are completing your independent practice questions, make sure that you have the top of the page labeled so I know what you're sending in. Make sure your questions are labeled 1, 2, 3 or in the corresponding portions there. Just show me your work. You don't have to rewrite the questions. And once again, you can also print it out if you happen to have a printer. If not, perfectly fine. Just make sure once you complete your independent practice questions that you then go into your Google Classroom and submit that independent practice. Since we're about a third or close to 40% of the way through our specific unit that we just started on circles, what I'm going to do is give you kind of like an overall review type of questions that you'll see on Jupyter coming up. Those review questions normally would qualitate them as something like a quiz, but considering the environment that we're in right now, they're just going to be a class grade, but those are going to be graded for accuracy. So those are going to have questions from 8.1, 8.2, and today, which is considered 8.4. If you do need help, once again, please check me out. Office hours, those are from 1:30 to 3:30. You can catch me on Zoom or catch me outside. It's up to you.